All right, here we're looking at example 5. We're supposed to use a graphing calculator to graph 1/2 y squared equals x. Then identify the vertex and the direction the parabola opens. Here we're starting to graph a couple of different, they're called conic sections, but we're just going to look at the different figures. We're going to be graphing a parabola and a circle. So the first thing we want to do when graphing this is we notice that the y squared is over here with some other stuff and x is all by itself. Well, that makes it pretty difficult to graph, so we're going to first solve for y. So in order to do that, I first write my original equation. I notice that this y squared, since I'm solving for y, is being multiplied by 1/2. So I want to get rid of that. So I divide by 1/2. And I know that dividing by a fraction is the same thing as multiplying by the reciprocal. So I multiply each side by 2, which gives me y squared equals 2x. And then I can go ahead and I take the square root. So the thing to remember when I take the square root of something, to solve for it, I have the plus or minus. And this is just something I always have to have when I take the square root of something. Okay? So then I go ahead and I graph both radical functions. And by both radical functions, I mean first I take this positive and I come up with some values, and then I take the negative and graph those as well. So here are the two different equations that I'm graphing. And I can do this several ways. I can use my graphing calculator, but then I can also, just pick some variables, pick some values for this x, and plug them in and solve for y, and then graph those points as well. So here's what this graph looks like. So my first equation, and we're looking back at our transformations that we learned in our last video in the last part, that my positive square root function is above the x-axis. This negative outside, is one of my transformations, and it reflects the same equation that I had across the x-axis. So this is what I end up getting. So the last thing I have to figure out from above is what the vertex is and which direction the parabola opens. So the vertex is the point in the graph where it changes directions. So I can see that my graph is going to the left, to the left, to the left, to the left, and then it stops and turns and goes to the right. So one thing I'm looking at is this graph, this parabola, is no longer a function. Now remember, when we're talking about a function, we can do the vertical line test. So here's my vertical line. Okay? So if I take this line and I scan it across my graph, if I touch more than one point at any time, the graph is not a function. So here I see that I'm touching several places at once. I'm touching right here, and it touches right here. So I know that this parabola is no longer a function. Okay? And any parabola that opens to the left or right, opens around the x-axis, is not a function. And this is one way I can test that. Okay? So the other thing that we're going to be graphing here is a circle. Okay, on that last slide we graphed a parabola, and we noticed that we had a y squared and an x by itself. That's one way to know for sure that it's a parabola. Here for circles I have an x squared and a y squared. Both of them are squared. Okay, so then I have to identify the radius. Now remember, a radius is the distance from the center of the circle to the outside, and the intercepts. I want to see where this circle crosses my axes. Okay, so first thing I want to do is I first solve for y. I go ahead and I write my original equation, and then I want to get the y's by themselves, so I subtract the x squared from each side. And then once I have that, now that the y squared's by itself, I can take the square root of both sides. Again, just like before, whenever I take the square root, I have to have a plus and a minus. So now I can graph my function. Except this is no longer a function, as you'll see in just a minute. Okay, so here's my two equations. I have the positive and I have the negative. Okay, and this is what I end up with, is my circle. So what I can see is the radius goes from the center, which in this case is my origin, out to 4. And my intercepts are at plus and minus 4 on both the x-axis and the y-axis. You see that this is a very strange looking radical function, and that's because I have this x squared term in here. At this point, you don't really need to understand the y behind it, and that's just fine. The biggest thing to recognize, is I have half of my equation above the x-axis, and then this negative in front flips it across the x-axis, so I have a mirror, or my reflection. Okay, so here's exactly what we were saying, that the radius is 4 units, and that my intercepts are plus and minus 4, and plus and minus 4. Okay, so now we're going to look at these two things again. So use a graphing calculator to graph this equation, negative 4y squared equals x plus 1, then identify the vertex and the direction the parabola opens. And I know that this is a parabola because I have a y squared term and then just an x term. So I want you to go ahead and answer these questions, graph it. You can first solve for y and then graph points, or use a graphing calculator. If you don't have a graphing calculator, go ahead and use Desmos. Then I want you to answer what the vertex is. What point is the vertex at? For number 6, we're going to use a graphing calculator to graph this equation. Okay, so I know that this is a circle because I have an x squared and a y squared. If I just had the y squared, it would be a parabola. But since both of my variables are squared, I know that that is a circle. So I can go ahead and I can graph this. First by solving for y and coming up with points, or using my graphing calculator or Desmos. Then what I'm going to want you to identify for me is what the radius is of this circle. Okay, so now back up to number 5 and my parabola. So the vertex. When I graph this equation, I can see that this opens to the left, and my vertex is at negative 1, 0. And soon we're going to talk about where these points are in this equation, so we don't have to do all of the graphing. For number 6, after I graphed my circle, which I knew was a circle because I have an x squared and a y squared, I see that my circle is centered at the origin and that my radius is 5 units. That also means my intercepts are a plus minus 5 and a plus minus 5 on the x and y axes.